Now, let's talk about the perplexity. The perplexity is a typical metric that is used to assess models that are trained for language modeling. It has this interesting formula. So this metric is assessed on a test set, and let's look at the different elements. So P here is the probability of the if token in the test set, and T is the total number of tokens in the test set. So the formula here is a minus of the average of the log of the probability of the tokens to the power 2. So let's try to understand what that means. So let's imagine that in a test set, we have this type of data. So we have the quick brown fox, and when it comes to the labels, it corresponds to quick brown fox. We just shifted the tokens. And maybe we have another sequence, jump over the lazy dog, and this corresponds to over the lazy dog. And we have the end of sequence tokens and the padding tokens. So let's try to compute the perplexity. So if we were to inject this data into the model would predict some probabilities for each of the tokens. So maybe for the word quick, it would predict the probability 0.4, and for the word brown, it would predict the probability 0.6, and etc. for all the different words and tokens that we have in the data. Okay, so now the perplexity would look like something like that. So you remember that we had a sum of logs, which is equivalent to a product of the different probabilities as part of the log. And we take all the probabilities and we just multiply them within the log and we divide by the number of probabilities. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 different probabilities and we divide the log of it by 8. And we take the minus and we take the power of 2 of it. And this is the perplexity. Okay. So now let's try to understand what the probability means. So when we have the probability associated to the word quick to be 0.4, what we have is an estimate of the model to predict, condition on the word the, what is the probability of the word quick. Similarly, when we have the probability for the word brown to be 0.6, what we have is an estimate of the model to predict the word brown, condition on the words the and quick. And similarly, when we predict the probability to be 0.5, so for the word fox, what we have is an estimate of the model for the probability of the word fox conditioned on the word the, quick, and brown. Now let's take the log of those probabilities and divide by the number of probabilities that we have. The number of probabilities that we have is 3 here, so we divide by 3. So 1/3 of the log of each of the probabilities, and we have a minus sign for each of those terms. This term here is the cross entropy per token. So this is a measure of how well the model predicted that the right word to predict was the word quick. And same for all the other terms. So each of those terms are per token cross entropy. So this whole thing here is the average cross entropy as it is measured on the test set. So the average cross entropy is 0 if the model is very confident in predicting the right tokens, and it is plus infinity if the model is very wrong in predicting the right tokens. So a good model minimizes the average cross entropy. So how does this relate to the perplexity? The perplexity is actually 2 to the power average cross entropy. So we are just taking the average cross entropy and we are taking the power of 2 of it. And this gathers the perplexity. So the perplexity is equal to 1 if the model is very confident in predicting the right tokens, and it is equal to plus infinity if the model is very wrong in predicting the right tokens. So the perplexity tells us how confused is the model in predicting tokens. We want a model that is not confused, so we want a model that is certain. So why don't we use the average cross entropy? So both of those metrics can be used, but the perplexity has the advantage that it can be interpreted as the effective vocabulary size used by the model when predicting the next word. This comes from information theory. So for example, a perplexity of 100 means that on average, each next word is as uncertain as if it were being chosen from 100 equally probable options. This provides a straightforward, intuitive measure of a model predictive capabilities.